Important milestone. We are starting object-oriented programming, or OOP for short. If variables and methods are like building blocks, OOP is the blueprint behind the Ant-Man suit. It tells us how things should be made and how they should behave. So what's a class? A class is like a blueprint. Imagine a car blueprint. It defines what every car should have, like brand, model, price. But the blueprint itself is not a car. And what's an object? An object is the actual car built from the blueprint. Example, class car, string brand, string model, in price, void drive, system.out.println, brand model is driving, public class car demo, public static void main string args, car1 equal to new car1 dot brand equal to Tesla, dot model equal to model 3, dot price equal to 40 grand, car2 equal to new car2 dot brand equal to Toyota, dot model equal to Corolla, dot price equal to 25 grand, system.out.println, car1 dot brand dot model dot price, system.out.println, car2 dot brand model price. And we'll call the methods call1 dot drive, call2 dot drive. So the output will be car1 is Tesla Model 3 40 grand, car2 is Toyota Corolla 25 grand. Tesla Model 3 is driving, Toyota Corolla is driving. How to think OOP? Class is the blueprint. Object is the real world thing created from the blueprint. And the variables inside class are properties like brand, model, price. And the methods inside the class are behaviors like drive, brake, honk. So this is the foundation and everything in OOP builds on this. Today we learned about classes and objects. But did you notice something? When we created a car, we had to write car1 dot brand equal to Tesla, car1 dot model equal to model 3, car1 dot price equal to 40 grand. That's a lot of repetitive code. Imagine creating hundreds of cars and hundreds of user accounts. It will take forever. That's where constructions come to rescue. So what's a constructor? A constructor is a special method inside a class that runs automatically when you create an object. Helps you to set the initial values of that object. Has the same name as of the class. Think of it like Iron Man suit auto-fitting onto him. You don't manually attach each piece. The constructor just sets everything up in one go. Let's say we are making a system for user accounts. Each user has a username, an email, and an age. Instead of setting them one by one, we'll use a constructor. So let's write a code. Class user, string username, string email, int age. Constructor, user, string username, string email, int age. This dot username equal to username, this dot email equal to email, this dot age equal to age. Void display info, system.out.println, username plus username, email plus email, age plus age. Public class user demo, public static void main string args, user1 equal to new user, Tony at stock.com 25. User2 equal to new user, stock at stock.com 30. User1 dot display info, user2 dot display info. And the output will be username Tony, email Tony at stock.com, age 25. Username stock, email stock at stock.com, age 30. Constructors save time by setting up objects in one step. This dot username equal to username, meaning we are assigning the value passed into the constructor to the object's property. You can create as many objects as you want with less code. Today we learned about constructors, how they make object creation easier. But today we'll take it one step further and introduce two powerful concepts, the this keyword and the constructor chaining. So what is this keyword? In Java, this refers to current object. Why do we need it? Because sometimes variable names inside a constructor or a method can confuse Java. For example, class user string username, user string username, this dot username equal to username. Here, this dot username refers to object's variable. Username refers to the parameter. Without this keyword, Java wouldn't know which one you're talking about. And what is constructor chaining? Constructor chaining means one constructor calls another constructor inside the same class. We use this to call another constructor inside the same class. Why? To avoid repeating code. For example, login and register forms. Think about an app. If a user registers, They give us username, email and password. But if you just want to log in, they give us username and password. So we can write two constructors for that. Class user, string username, email, password. Constructor for registering user with email, password and username. User, string username, string email, string password. This dot username equal to username. This dot email equal to email. This dot password equal to password. Constructor for login. User, string username, string password. This username not provided password. Void display user, system.out.println, username plus username, email plus email. Public class user demo, public static void main string args, user reg user equal to new user, ironman, Tony at stark.com, javis123. User login user equal to new user, ironman, javis123. Reg user dot display user, login user dot display user. And the output will be username equal to ironman, email equal to Tony at stark.com. Username equal to ironman, email not provided. In here, this keyword is used to refer the objects variable. This constructor is used for constructor chaining. Constructor chaining avoids duplicate code and makes things cleaner. Yesterday we talked about this keyword and constructor chaining. And today we are stepping into one of the coolest OOP concepts, inheritance. So what is inheritance? Inheritance is like passing down the traits in a family. If your dad can play guitar, maybe you also can. Or at least you'll inherit the skill. In Java, a child class can inherit properties and methods from a parent class. We use the keyword extends to do this. Let's say we have a vehicle class. Every vehicle has speed and fuel. Car and bike are special types of vehicles. They both share common things, speed and fuel. But also they have their own special features. Let's write a Java code so we can understand it more clearly. Class vehicle, int speed, int fuel, void start system.out.println, vehicle is starting. Void stop system.out.println, vehicle stopped. Child class car. Class car extends vehicle, int doors equal to 4. Void show car info system.out.println, car with doors, doors. Child class bike. Class bike extends vehicle. Boolean has kickstart equal to true. Void show bike info system.out.println, bike with kickstart plus kickstart. Public class inheritance demo. Public static void main string args. Car equal to new car. Car dot speed equal to 120. Dot fuel equal to 40. Dot start. Dot show car info. Dot stop. System.out.println, bike equal to new bike. Bike dot speed equal to 80. Dot fuel equal to 10. Dot start. Dot show bike info. Dot stop. And the output will be vehicle is starting, car with 4 doors, vehicle stopped. Vehicle is starting, bike with kickstart, true, vehicle stopped. So basically inheritance is the reusability. Instead of writing speed and fuel for both car and bike, we wrote it once in vehicle and reused it. The keyword extends make our class inherit from another class. Child classes can add their own features on top of the parent features. Think of it like Iron Man suits. The base Iron Man suit has the flight and AI in it. But then Iron Man makes special suits like Hulkbuster, Mark 85. They all inherit the same base properties but with extra power. That's inheritance in action. Yesterday we learned about inheritance using vehicle example. Today let's learn something even more powerful, method overriding. So what is method overriding? Imagine you have a parent class that defines a method. Now the child class says, thanks dad, but I'll do it my own way. That's overriding. Same method name, same parameters, but different behavior. Think of a printer. A normal printer prints in black and white, a color printer prints in color, a 3D printer prints an actual 3D object. All of them are printers, but they behave differently when you call print function. So let's write the code. Parent class, class printer, void print system.out.println, printing in black and white. Child class, class color printer extends printer, override void print system.out.println, printing in color. Another child class, class 3D printer extends printer, override void print system.out.println, printing a 3D object. Public class overriding demo, public static void main string args, printer p1 equal to new printer p2 equal to new color printer p3 equal to new 3D printer. p1.print, p2.print, p3.print. And the output will be printing in black and white, printing in color, printing a 3D object. In overriding, child class changes the parent's behavior. Use at override above the method to make it clear. This is runtime polymorphism. Which method runs is decided while running the program, not while writing the code. It's like Iron Man's Jarvis AI. The base AI is Jarvis, then came Friday, a new AI. Both respond to Hey Tony, but they give different behaviors. So far, we learned about inheritance and overriding. Now let's unlock a superpower of Java, polymorphism. So what is polymorphism? The word polymorphism literally means poly is many, morph is forms. It means the same thing can take many forms. For example, a payment can be done by Apple Pay, Google Pay, UPI, card or cash. But no matter how you pay, the action is always the same, making the payment. There are two types of polymorphism, static polymorphism and dynamic polymorphism. Static polymorphism is the compile time polymorphism. It uses method overloading. Same method name but different parameter list. Example, making a payment by amount only or amount and discount. Dynamic polymorphism is the runtime polymorphism. It uses method overriding. Which version of the method runs depends on the object you create at the runtime. Example, payment through UPI, card, cash, Google Pay, Apple Pay, all these things. The make payment method behaves differently at the runtime. So let's write the code for it. Let's have a parent class payment, void make payment double amount, system.out.println paying dollar plus amount. Static polymorphism. Void make payment double amount string coupon, system.out.println paying dollar plus amount plus using coupon plus coupon. Let's have a child class for card. Class card payment extends payment. Override void make payment double amount system.out.println paid dollar plus amount plus using card. Child class for cash. Class cash payment extends payment. Override void make payment double amount system.out.println paid dollar plus amount in cash. Public class polymorphism demo. Public static void main string args. Static polymorphism. Payment base equal to new payment. Base dot make payment 50. Base dot make payment 100. Discount 10. Dynamic polymorphism. Payment P1 equal to new card payment. Payment P2 equal to new cash payment. P1 dot make payment 200. P2 dot make payment 300. And the output will be paying $50, paying $100 using coupon discount 10, paid $200 using card, paid $300 in cash. Static polymorphism is the method overloading, which is decided at the compile time. Dynamic polymorphism is the method overriding, which is decided at the runtime based on the object. About encapsulation, which is basically the idea of wrapping your code like a protective shield. So what is encapsulation? Think about your phone's lock screen password. You type the password to unlock, but do you know how the phone is actually verifying it inside? No, that's hidden from you. You only interact with the public interface, the keypad. The internal working is entirely private. That's encapsulation in Java. You hide the internal details and only expose what's necessary. Let's write a code for user password management to understand encapsulation clearly. Class user, private string password, public void set password, string pwd, if pwd.length greater than or equal to 6, this dot password equal to pwd, system.out.println password set successfully, else system.out.println password must be at least 6 characters long. Public boolean check password string input, return this dot password dot equals input. Public class encapsulation demo, public static void main string args, user1 equal to new user1 dot set password 123, user1 dot set password secure 123, system.out.println user1 dot check password wrong pass, system.out.println user1 dot check password secure 123, and the output will be password must be at least 6 characters long, password set successfully, false, true. Here, private variables keep the data safe from outside interference. Public methods are like the door handles to interact safely with the private data. Just like you don't give someone your raw bank account database, you give them an ATM card and a PIN system to interact securely. Think of Iron Man suit. You don't get direct access to writing or arc reactor. You only press buttons on the inside interface and suit does the complex stuff. That's encapsulation. So in short, encapsulation is data hiding plus controlled access. It keeps our program safe, modular and easy to maintain. Moving into abstraction, one of the most important OOP concepts. So what is abstraction? Abstraction is all about hiding the unnecessary details and only showing what the user really needs. Think about an ATM machine. You insert your card, you press buttons to withdraw money, check balance, deposits, etc. Do you know how the ATM is connecting to bank's database? How the money is being verified or how it prints the receipts? No, all of that is hidden. You just see a simple interface. That's exactly what abstraction is in Java. Let's write a code for ATM machine interface. Abstract class ATM, public abstract void withdraw double amount, public abstract void check balance, public void insert card, system.out.println card inserted, please enter PIN. Class bank ATM extends ATM, private double balance equal to 5000, it override public void withdraw double amount, if amount less than or equal to balance minus equal to amount, system.out.println please collect your cash dollar plus amount, else system.out.println insufficient funds. It override public void check balance, system.out.println your balance is dollar plus balance. public class abstraction demo, public static void main string args, ATM equal to new ATM dot insert card, ATM dot check balance, ATM dot withdraw 2000, ATM dot balance, and the output will be card inserted, please enter pin. Your balance is $5,000. Please collect your cash $2,000. Your balance is $3,000. In here, abstract classes act like blueprints. They say what should be done, but not how. Different banks can have their own ATM implementation. The user doesn't care how the backend works. Abstraction makes code flexible, reusable, and easy to update. Think of Jarvis in Iron Man suit. Tony just says, Jarvis give me flight mode. He doesn't need to know every line of code Jarvis is running in the background. That's abstraction. So in short, abstraction is showing only what's needed and hiding the rest. What access modifiers? Basically the rules that decide who can see what's in your code. So what are access modifiers? Think of access modifiers like privacy settings on your social media. Some posts you make public so everyone can see it. Some info you keep private like your home address or password. Some things you share only with your friends or family. Java does the same with code. So there are 4 main access modifiers: public, private, protected, and default. Public, anyone can access it. Private, only that class can use it. Protected, can be used inside the same package and by its child classes. Default, package private, meaning it's only accessible within the same package. Let's write a code for public profile versus private data. Class user profile, public string username John Sena, private string password password123, protected string email john@wwe.com, string phone equal to +1 123456778, public string get password return password. Public class access modifiers demo, public static void main string args, user profile user equal to new user profile, system.out.println username plus user.username, system.out.println password plus user.get password, system.out.println email plus user.email, system.out.println phone plus user.phone. And the output will be username John Sena, password password123, email john@wwe.com, phone +1 2345678. In here, public username is just like your Instagram handle. Everyone can see it. Private password is locked away. Only you can access it. Protected email, shared only with the close connections, child classes and same package. Default phone, only people in the same package can see it, like a neighborhood. So why does this matter? Because access modifiers help keep your data safe and your code organized. You don't want every part of your program messing with the sensitive data like passwords, right? Talking about static keyword, one of the most important concepts in Java. So what is static keyword? Think of static like a shared property for all objects. Normally, each object has its own copy of variables. Static variables are shared among all objects of that class. You can access static stuff without creating an object. It's like having a shared scoreboard for all players in a game. Everyone can see the same score, but it belongs to the game, not a single player. Let's build employee count tracker. Class employee string name, static int employee count equal to 0. Employee string name this dot name equal to name employee count plus plus, static void display employee count system.out.println, total employees equal plus employee count. Public class static demo, public static void main string args, employee E1 equal to new employee Alice, employee E2 equal to new employee Bob, employee E3 equal to new employee Charlie, employee dot display employee count, and the output will be total employees 3. In here, employee count is static. It's shared by all employees. Whenever we create a new employee, the count increases for everyone. We don't need to use an object to check the total count. We can directly call employee.display employee count. It's like Iron Man building multiple suits, but the main AI system tracks how many suits exist. Each suit doesn't track itself individually. It relies on the shared system. So why use static? To share data across all objects, to create utility methods that doesn't depend on other state, to keep track of things globally in your program. To learn about the final keyword. So what does final mean in Java? Think of final as a big lock. Once something is marked final, you cannot change it. You can use final in 3 different ways: final variable, final method, final class. Final variable is like a value that can't be changed. It's like a constant. Final method, it can't be overridden by child classes. Final class, it can't be inherited. To understand the final keyword, let's write a code for salary cap. Class employee string name, final int salary cap 100,000. Employee string name this dot name equal to name. Void salary cap system.out.println name plus max allowed salary is $+ salary cap. Public class final demo. Public static void main string args. Employee E1 equal to new employee Alice. Employee E2 equal to new employee Bob. E1 dot show salary cap. E2 dot show salary cap. And the output will be Alice max allowed salary is $100,000. Bob's max allowed salary is $100,000. In here, we set salary cap as final. It can't be changed once given. If you try to set it to 120,000, Java will throw an error. This is useful when you have rules in a system that shouldn't be changed. Think of it like Avengers rule. Captain America's shield is always made of vibranium. No one can rewrite the fact it's final. So, where do we use final in real life? To define constants like pi. Pi is 3.14. To protect values in business logic like salary cap, tax rates. To make code safer and prevent accidental changes, we use final keyword. Wrapper classes and something called autoboxing. Don't worry, it's way easier than it sounds. So, what are wrapper classes? In Java, every primitive type like int, char, double has a special object version. These are called wrapper classes. Int, integer, char, character, double, double, boolean, boolean. So basically, wrapper class wrap primitive data types inside an object. So why do we need them? Because sometimes Java only works with objects. Like in collections, array list, hash map. You can't directly put int in an array list, but you can put integer. So what is autoboxing? Autoboxing means Java automatically converts a primitive into a wrapper object. For example, int num equal to 10, it is a primitive type. Integer obj equal to num. Autoboxing happens here. You don't need to write integer dot value of num. Java does it for you. And the opposite of autoboxing is unboxing. Integer obj equal to 20, int num2 equal to obj. This is unboxing. So let's write an example. Let's say we want to take input as integer and store it in a wrapper class. Import java.util.scanner, public class wrapper demo, public static void main string args, scanner sc equal to new scanner system.in, system.out.print, enter your age, int age equal to sc.nextint, integer age wrapper equal to age, system.out.println, you entered age wrapper, int again primitive equal to age primitive, system.out.println, unboxed back primitive plus age primitive, and the output is enter your age 25, you entered age 25, unboxed back to primitive 25. In here, int is like the raw number. Integer is putting that number inside an environment suit. Now it's an object with superpowers. Autoboxing is Java saying don't worry, I'll put it in the suit for you. Unboxing is Java saying okay, I'll take it out of the suit now. Something modern and cool that came with Java 10, the var keyword. So what is the var? Normally in Java, when we declare a variable, we write the type explicitly. Example, string name equal to John, int age equal to 25, double salary equal to 50k. But with Java 10, we got var, which allows Java to infer the type for you. So the same thing can be written as var name equal to John, var age equal to 25, var salary equal to 50k. Java knows which is string, int or double. This makes your code looks cleaner and more modern. Var does not mean dynamic typing like in Python or JavaScript. The type is still fixed at compile time. Once inferred, the type cannot be changed. Var age equal to 25. If you write age equal to 10, it will give you an error. You can only use var when the variable is initialized immediately. Var num, it will give an error. Let's write a code using var. Public class var example, public static void main string args, var name equal to Tony Stark, var age equal to 48, var power equal to 99.9, system.out.println name, age, power level, power. And the output will be name Tony Stark, age 48, power level 99.9. So why use var? It saves time and typing. It makes our code shorter and more readable. It's great for complex data types like when you're working with generics. Like without var, you will be writing hash map string list integer map equal to new hash map string list integer. But with var, you'll just write var map equal to new hash map string list integer. So think of var like Java is an Iron Man. You don't need to tell him every single detail. He figures it out for you. But once he knows, that's fixed. Today we are going to take all the OOP concepts we learned so far, like classes, objects, constructors, methods, encapsulation, and use them to build a mini banking system simulation. This will feel like a real world app where user can create bank account, deposit money, withdraw, check their bank balance, So let's create the bank account class first. Class bank account, private string account holder, private int account number, private double balance. Let's build a constructor. Public bank account, string account holder, int account number, double initial balance. This dot account holder equal to account holder. This dot account number equal to account number. This dot balance equal to initial balance. Let's have a deposit method. Public void deposit double amount. If amount greater than 0, balance plus equal to amount. System.out.println deposit dollar plus amount plus successfully. Else system.out.println invalid deposit amount. We should also have a withdraw method. Public void withdraw double amount. If amount greater than 0 and amount less than or equal to balance. Balance minus equal to amount. System.out.println withdraw dollar plus amount plus successfully. Else system.out.println insufficient balance or invalid amount. And a check balance method. Public void check balance system.out.println account holder plus account holder, system.out.println account number plus account number, system.out.println current balance plus balance. And testing the banking system in main. Public class banking system, public static void main string args, and we need to create a new bank account. Bank account 1 equal to new bank account, Tony Stark 1000 5000. And to perform transactions, account 1 dot check balance, account 1 dot deposit 2000, account 1 dot withdraw 1500, account 1 dot check balance, and the output will be account holder Tony Stark, account number 1001, current balance $5,000, deposited 2000 successfully, withdraw 1500 successfully, account holder Tony Stark, account number 1001, check balance 5500.